So I'm gonna talk about what I learned from a perspective of data types in SQL and try to explain to you all the concepts based on what I know now. The first concept that I learned that is very fundamental to everything, I think, is that how you store information in SQL takes up memory. So the more precise you are, especially from a perspective of numbers or the length of your characters that you're using, that all is taking up some form of memory from your database, which is why you have to be mindful from a performance standpoint around what data type you're using based on what level of precision you need, and make sure to check yourself before you wreck yourself, if that makes sense. I can't believe I just said that. All right, the next thing that I learned is that there's two concepts in how you bring different data types together in SQL. The first one is data type precedence. So as the name suggests, certain data types, as you're combining them together, will take precedence over the others. So if you are, for example, combining a datetime field, which is datetime2, with datetime period, those are two actual data types that exist in SQL, then datetime2 will take precedent in outputting a step. So it converts datetime into datetime2 so that it gives you the output that you need. That's the data type precedence concept. The second concept is collation. So collation just means the way that SQL stores information by default. So the way it does that is, if I'm not mistaken and I'm operating out of memory here, is it stores Latin characters, is not case sensitive, but is Unicode sensitive, which means it's sensitive to specific accents and things like that based on foreign languages. That stuff matters. So that's collation. The next thing you should know is like the different data types that we have. So there's dates, there's spatial data, there's geographic data, and I feel like these things are pretty self-explanatory, so I won't go into details with them. All you should know is that there's different level of granularity, meaning detail of the information can be represented in different data types based on what you need. There's also binary, which is basically images that's stored in 1010 format. Binary code is the basis of all computation, and that's how that works. And there's exact numbers, which is pretty straightforward, and floating numbers. So the reason why I was stuck on float numbers for a while is because it turns out that float numbers is a concept that's important for computing, period, not just SQL specific. So I got into these rabbit holes where I was trying to understand, why do float numbers even exist? And where does that matter? And when would I use it versus when would I not use it? So the main thing that you should know is for computing, again, it's all about memory, but floating numbers were created so that you can do huge computations with either very, very tiny numbers, or like the diameter of an atom, or very large numbers like the distance between galaxies, in a scalable way that wouldn't completely max out your memory on your computer. And the way that works is through the scientific notation, which, if you guys don't remember from high school days what it actually means, it's 1.56 times 10 to the exponent of 5, for example. That's the scientific notation, which means that it actually has 5 different zeros after that, but we are making it simpler so that we can calculate it faster when we're trying to multiply different information together. In SQL, there's something called float 23 and float 50, I want to say, or 52. I don't remember, but it was like either float 52 or 50. Either way, that number in the parentheses will represent the exact number of bits that it's taking up. So the memory is going to take up from your database. That's where that plays into SQL. Otherwise, we don't have to really worry about it. But from a computational standpoint, I thought it was really fascinating because the existence of float numbers allowed us to have the computers that we have today that do these amazing computations very quickly. But I did not realize how much it leads to lack of precision. And apparently that's a main concept that is a problem for programmers specifically. Now, I'm not a programmer, so I don't deal with that problem. But it was kind of cool to figure out the limitation of a computer, as weird as that sounds, based on what humans did to make it scalable. So that's it. That's what I learned so far in this part 2 of SQL training that I'm taking. I'm about to go into part 3. I hope this helps.